Alright guys, so today we would be talking about networking and the concept of networks, how networks are used in computers and how different computers communicate with each other. Okay, so let's say you are on your smartphone and you are chatting with your friend, then how is that made possible? So there comes the concept of networking, which make these things possible, which makes different nodes or different computers communicate with each other. So it's very important, and I would say for any person who wants to understand uh, the realities inside computers uh, are the concepts which go on the working of any communication between computers. So you need to understand networking as well. Here we will just get an overview of what is networking. We'll try to understand some basic concept, and we'll also try to get familiar with different keywords for what purpose they are used, and these sort of things. So we'll learn in this lecture. Okay. So moving forward, in this chapter, we would try to understand what can be done online, what are computers, how are computers connected, what are the physical properties of networks, how does the computer know how to communicate with the network, and can all computers talk to each other. So we'll try to understand these questions, and also we'll try to get as much as like get understanding of it as much as possible about the networking of different computers. Okay. All right. So first thing, everything is connected to everything. In terms of networking, if you look at the way how computers work, how the internet as a whole work, then you would get the idea that everything in the whole uh, networking concept or internet is connected to each other. Everything is connected to each other. Your mobile is connected to something through whether your Wi-Fi or something else, and it's totally connected with the all the networks. That's how the internet work. And when you get a uh, get a collection of these interconnected computers, you can do lots of stuff. Okay, so imagine that there are a billion of people on Earth, and everyone have computers. Okay, now if you want to connect with those people, it's not that difficult because everything is connected, and you can reach out to every person on the other side of the planet. So you can do banking, you can pay bills, you can buy groceries, you can book vacation travel, send messages, and so many other things. So if everything is connected, then it becomes very easy for you to communicate with those people or those devices in order to get whatever you want from the communication. Okay, so if we try to formally define the network is actually a collection of computers. It's a collection of computers or terminals, printers, and other devices linked either by physical or wireless means. So that's simple definition of network in computer sciences. If in a broad view, if you just try to define try to define a network, that might be different. But in a mm, in computers or in the study of computers, computer science or computers, we would define network as a collection of computers, terminals, display terminals, printers, or other devices which have the capability to get connected to other devices in the network, or linked either by physical or wireless means. Okay, so that's what we call as network. So where does this concept of networking came from? How it was made possible for computers to connect with each other to communicate with each other. How was that made possible? So it goes back to 1996 when ARPA, Advanced Research Project Agency, it's a United States Defense Department research organization. It was a military organization uh, which had the aim uh, to which had the aim to focus which had the aim to create something uh, where different computers could be connected to each other and the research could be made easier. So that's why this project was funded and focused major development efforts in computer networking. It was done by ARPA, and ARPA goal was to promote research in advanced future technologies by funding universities and industry research proposals. And the result was thousands of databases became available to public by networking them with each other, and that's how the networking came in. Now, computer networking. So there are two main concepts, two main terms which we need to understand here. One is internet, or and the other is internet. So the spelling is same, but one is with lowercase I and one's uppercase I. So internet basically it refers to with capital I refers to the World Wide Web or World Wide Network, which we call the whole World Wide Web, which is connected with each other, is called as internet. So it's a worldwide network connecting millions of computer networks for the purpose of exchanging data and communication using special rules of communication. So we'll talk about rules of communication in the later part of this lecture. For now, just this is the basic definition of internet and internet. It is also the same thing, uh, and it is a word used for any network connecting two or more computers together. So when two or more computers are connected together, we call that internet. When two or more devices are connected to each other, and the human need to communicate have motivated humans creativity. So the human always needs to communicate in a broad scale. It is considered as one of the most important skills which have made us possible to evolve so much quickly due to communication. So due to that need, uh, which motivated humankind to create this sort of stuff which we are doing nowadays. So for example, the human need of how does the human need to communicate has motivated humankind's creativity. Now, the cave dwellers drew picture on walls. They wanted to communicate something with other people, therefore they drew something in picture in caves. Okay, we could find that in different caves or archaeological sites. We could find that, and smoke signals were also used to communicate, used for communication, or drum rhythms, passage messages, and then American pointers, Pony Express, Welfare were those walls, and then Alexander Graham Bell, who invented the telephone. This was the groundbreaking invention by Graham Bell, who invented the telephone for communicating with each other via telephone. So types of connection of computer into network, physical versus wireless. So these are the two basic types of connection which could be made. It could be wireless or wired. Okay, so it could be wired means physical. So the first type, physical connection, is any computers are physically connected with each other. For example, if you have ever seen in your universities or somewhere where different cables are connected to each other via wires. Okay, so that becomes a kind of, we call that lab, where every thing is connected with each other. Are in offices, in more modern offices, every device is connected to each other via wires. So that's a physical connection. Okay, and there are three most common physical wires or physical links which are used uh, to connect computers with each other. One is twisted pair cables, coaxial cables, fiber optic cables. So these are the three type of cables which are used for connecting computers with each other. We'll discuss these one by one. So twisted pair cable, these are mostly used in nowadays, mostly used in connecting different computers in offices and different labs. So it makes two wires twisted together. So this is how it looks. You can see in the picture, and the twisting of the cables make them less susceptible to acting like an antenna and picking up radio frequency information or appliances noises. So the coding these cables and also twisting them and coding into the insulators make them more less susceptible to other radio frequencies which could create noise in the network or in the communication, or which could corrupt the data packets which are being passed through the network. Okay, so telephone company use twisted pair cables wired to link telephones. That's obvious. We mostly it's being used in our computers to get connected with each other. And there is one also a cable called coaxial cable, which is mostly used in TVs. If you ever used a dish TV in your, have you ever used that? That it's being used in those dish TVs. I think it's not being used nowadays, but it used to be a very groundbreaking technology around 1020, maybe more than that. So one of the wires is woven of fine standard strands of copper, forming a tube. The wires mesh around solid copper wire that runs down the center, and the space between has a non-conducting material, makes them more impervious to outside noise. So it is also being used, and the purpose of insulating this much is so that no other frequencies from outside could not be affect the signals which being passed through the copper wire. If you have had the opportunity, or you have some additive in your house or somewhere, yeah, you could check this through that as well. All right, then we have optical cable as well. I think uh, the modern Wi-Fi uh, are optical. These are most used the Wi-Fi connections. These are mostly optic fibers which can be used, and it uses light. Light is obviously an electromagnetic uh, you can say wave or particle. There's a dual if is a kind of physics kind of thing, so you must have idea about what the form of light and how does it work. So it can transmit more information down a single distance. It can send a wider set of frequencies. So that for that purpose we use this optical fibers, because it sends different frequencies at the same time, and also it sends information in each single strands, and each cable can send several thousand phone conversation on communication. So therefore we uses these fiber optic cables. All right, so these were all physical medium of communication which we just discussed about. The twisted pair cable, the fiber optic cable, and also the coaxial cable, which is I don't think that this is being used, but it also is once it was also being used. So now the second part is we have wireless means of communication as well. So wireless connection. For example, if you're connected to your Wi-Fi, that's also wireless. The Bluetooth connection is also wireless, and there are so many other things which are kind of wireless kind of connection. So the link is made using electromagnetic energy that goes through space instead of a long wire cable. These three type of wireless communication commonly used in networking: infrared, which is I think your Wi-Fi routers use infrared. Then radio frequency, this is also being used. Then we have microwave, that's also being used. So we'll discuss these one by one. All right. So first off, we have infrared. It's commonly used in TV and VCR for remote control. Have you ever, uh, like, if you have your TV or something in your home, you might have idea how does the remote control work. So these infrared are being used for remote control. Use infrared frequencies of electromagnetic radiation that behave much like visible light and must be in the light of side, often used to connect keyboard, mice, and printer. So this is being used, and also it's sort of your Bluetooth connection also, I think, uses infrared. Maybe I don't know. I'm not sure about that. But these mouse and all these things, mouse, remote control, and these use infrared. And one more thing, it is the one of the weakest electromagnetic radiation, weakest frequencies. Then we have radio frequency. Your radio frequencies is used in many. It function even though line of sight is interrupted. For example, your Wi-Fi router is placed somewhere else outside your room or somewhere, but still you get the connection, which uses radio frequency. Not commonly used because of the possible interface from other sources, like the old thing used to have radio connection, which I don't think nowadays not being used. Maybe I think the walkie-talkie type of thing they used to have these used to use a radio frequency. I'm not sure about that, but that's the way the radio frequency were used for. Then we have microwave, often used to communicate with distant location, must be in line of sight. Satellite communication used microwave. So nowadays, in communication, like in remote areas, you would see the communication towers, or we call that as communication towers, where you would see these different, not in remote areas, but also in cities as well, for the the SIM network, or different network. For example, there is Telenor or some other things which uses this type of microwave discs devices for communication. So that's how we can use microwaves as well. So this was just a simple overview of how these microwave, infrared, and radio wave frequency are used. I just it just give you the overview of how these are used. I didn't go much deeper into the physics concepts, which tells in the which if you're curious enough, you could check that out how we can use microwave, how it's used for communication, and also the radio frequency and infrared as well. So next we have properties of transmission. There are 5 basic properties of both physical and wireless links. Uh, and first one is type of signal communication, be it analog or digital. We'll discuss that later. And speed at which the signal is transmitted. The type of data movement allowed on a channel. What type of data movement is being used, or how does communication is held, communication and the method used to transport the data, and single channel, baseband, or multi-channel, like TVs and all that. So first off, we have what is the type of signals communicated, whether it's analog or digital. Those signals that vary with smooth continuous changes are called analog. uh, a continuously changing signal similar to that found on speaker wire or high fidelity stereo system. So at the bottom of this slide, you could see that there is one analog and what is digital signal. So the one with this one you can see this is the one in the left side is analog and the other is digital. Okay, so those as and the digital is those signals that vary in steps or jump from value to high value to low value, and they are usually in the form of pulse of electrical energy represented 0 or 1. So that's how digital works, digital and analog type of signals work. I think you just get the idea how does this work. Basically, if you look at the analog signal, it is a form of continuous wave, okay? Continuous wave of frequency or continuous signal. But if you look at the digital or discrete, it is in a form of either it's low or it is totally zero, okay? So here you can see that it is at the top, then at bottom, then at top, then at bottom, and that's how it works, okay? Now the next thing is speed at which a signal is being transmitted. So how can we measure that whenever you are sending some messages or something, at what speed does it being transferred through the medium? So for that we use two measuring system. One is bits per second, uh, which is used to measure the digital signals. Is the number of bits, zeros or ones that travel down the channel per second. And then we have baud rate. It's the number of bits that travel down the channel in a given interval. So that are the two ways we could you could measure the speed at which data is transmitted, or signal is transmitted through a data channel. Okay. Then we have modem here. I think we need to discuss so many other things, but for now let's discuss modem, modulator, and demodulator, just a short form modem. I think nowadays mostly modem is not that used much, but a different version of it is being used. Okay, so router is a kind of version of this modem. It is what is used for it for outgoing. It converts binary data from computer digital into telephone compatible signals. So whenever we are sending any signals from the telephone to other, it converts that into analog signals. And when something is coming back, data is coming back, a modem convert it the telephone signal analog one into binary data for digital computer. So that's why it's being used. It can be external or internal in your computer. So then the speed of signal. So here we have some samples of bits per second and baud rates of speeds. So have 300 bps, painful slow to call this level reader. 200 bps good reader can keep up, and 24,000 bps speed reader would get the general idea impossible to read, and then 14 kbps. So that's, yeah, um these are speed restricted maximum speed on modem. So these are just general speed of signals in a modem. Okay, you get the idea, I think. Now the type of data movement allowed in the channel. What are the data movement types? So first one we have simplex. In simplex there's only one way transmission, like the TV or cables, or whatever you're using, you're watching TV or something, that's one way transmission. Okay, it's being transmitted from the TV channels, and that's being consumed by you. That's one way channel. You cannot talk back to your TV and all that. And then we have half duplex, where transmission is dual way. Like you can also communicate with, but there's a uh, there's a you can only communicate one way at a time. Like let's say you're communicating with our phone, you cannot communicate uh, at the same, like the person on the other end is communicating the same way, and you can get back at the same time. That's not how it works. For example, the walkie-talkie, that's how to like kind of transmission walkie-talkie. If you have an idea about that, that's a half duplex way of transmission. Then we have a full duplex, which is two-way transmission at the same time. You can send and receive data packets at the same time. There is that's full duplex, and in modern phones that's being used. So the methods used to transport the data, like when we are communicating with someone, we are essentially sending data packets through our phones. Okay, so now there are different methods which we can use it to transport data from our phones or from our network to other. So one is asynchronous transmission, which where information is sent byte by byte, which is cheaper and most commonly used nowadays. Then we have synchronous transmission that is sent in a larger packet than in small piece, preceded by special information concerning error detection block size. So these modems are expensive but very fast. So the synchronous ones just send the data in a large block form, and yeah, that's it. It's very expensive and but it's very fast. Then we have four channels. There are different channels. The channel could be single channel, a single path for communication. There could be multi-channel communication as well. So what is channel? Channel is basically a path of signal, and single channel is capable of only sending, receiving one signal at a time. It could be either just send at a time or receive at a time. So that's a single channel. Like phone line, single phone call. So phone line is a single channel. Then we have multi-channel. It's capable of more than one channel at a time, like fiber optics, microwaves, light transmission. These are multi-channel way of communication. Okay, how it's possible to measure the capacity of computer link? How we can measure the capacity of any computer link? Let's say you are using twisted pair cables in your communication. So how would you measure that how much data could be sent from this cable? Okay, so that's where the bandwidth come in digital way of communication or uh, digital devices. So it the bandwidth measures the number of bits per second that can be sent over a link, and the wider the bandwidth, the more diverse kind of information can be sent. So simplest is voice. Most of the sketch is moving video. Okay. So it's bandwidth is basically how many number of bits you can send over a network or over a cable or over a link per second. That's what we call as bandwidth. Okay. And then for analog, it's the difference between the highest and lowest frequencies that can be sent over an analog link like phone lines. It's measured in hertz. So for both, the wider the bandwidth, the more information can flow over the channel. So it's obvious that if your channel is big, if the that could more information could be sent through that. Take an example. Let's take an example of a pipe. Okay, water pipe. The wider the pipe, the more water uh, could be travel to the pipe. The more water could travel to the pipe, the thinner it is, or the or small it is, less water will be able to pass through that. So yeah, that's how we could just simply you would get the analogy out of it for how does the bandwidth and it works. So there are some typical cable bandwidth used in local area network. For example, twist pair, coaxial cable, fiber optic cables, and different bandwidth of these things. There are different bandwidths given. Nowadays, the bandwidth goes it's in GPS, so you might get the idea from this that how does this bandwidth that concept works and how it's measured. So two paths to connect computers to network. There are two things which need to be there in order to make the communication between two computers possible. One is hardware. Hardware is needed to connect the computer to the network. You need to have particular hardware, which is important in order to get in order to communicate for your computer with other. And also there is a need for software which will control the hardware to make it possible. Uh, so software standards will be discussed in the next section. So in this section we are going to explain different protocols which are used or software standards which will be used. So we'll discuss that. Okay, so node. What is node? A node is, well, it's nothing but a generic name given to all devices hooked up to a network. Now, in simple word, your laptop is a node. Okay, your phone is another node. This is the simple way. Any computer or whatever, any computer or digital devices which has the ability to connect to any network is called as node. Okay, so that's the simple definition of it. Each node must have a unique address assigned to them by the network either direct connected or those that are not directly connected. So each node must have a unique address. So if you have an idea about IP address, okay, Internet Protocol address, that is the address which is being given to every device for them to communicate with other device in the network. So we'll discuss that. It's a very important concept. The IP address. It's a broad topic, and we'll discuss that. It's a very important one in the later sections. Network are either direct connected or those that are not directly connected. So what is mean by direct connected network? Those whose node have direct connection through either physical or wireless link. For example, you are connected to your mobile phone, or let's say your mobile phone is connected to another mobile phone via Bluetooth. Okay, Bluetooth device. Then we could call it direct connected network. Or let's say your two computers are connected to a wire. Okay, a cable, a twisted pair cable. Then we call that is direct connected network. And now, what's point to point? The simplest version of direct connected network connected to computing systems. Example, point to point home to ISP. ISP, that's point to point connection. ISP, what is ISP? ISP is Internet Service Provider. These are the people or the company who provides you the internet, the Wi-Fi system, and all that. So the connection from those people to your home is an example of point to point connection, which is an example of direct connected network. Okay, an example of network that's not directly linked is internet. You go and search for something and you get different data from the internet. That is an example of indirectly connected network or not directly linked network. So that's internet. Okay, so there are various physical organization of networks, like how there are the various way in which computers or nodes could be linked together. First one is bus network. In bus network, there's one cable from which with which all the other computers or nodes are being connected to. In the picture, in the left side, you could see. In the right side, you could see that there is a bus at the top and bus network. So the data packets are being sent over this over this medium or wire in between, and then each computer get the data packets, and it reaches where it need to be and is accepted by that only. Okay, and then we have ring. It's also kind of network where everything's linked together. We are different. We are connected together via wires, or it could be in physical means it's no a ring could also be created, but in physical means it is like that. Just you can see in the right side as well. So a message sent out from one node is passed along to each other in between until the target node is received. So how does it work? Just let's say you are holding your hands with your friend in a circle. I think you must have done that somewhere, and you are just passing something over from one person to other, one person to other, one person until it reaches the person who need it, okay, who really need it. So that's how this ring network works. All right, then we have star network. In this network, every node is linked to a central node which is in between, and all messages are routed through the central node which delivers it to the proper node. So it's like there's one person in between, and there are other person attached to that, and the message reaches in the central node, and then it's delivered to all the other nodes uh, which are required, and the central node decides that which node needs this packet. Okay, or this data. So that's how it works. Then we have for tree network, in which different computers are connected in a form of tree shape. So it looks like an upside down tree where end nodes are linked to interior nodes that allow linking through another end node. And so that's how a tree network work, or hierarchical network. And then we have fully connected network, which we also call as mesh network or mesh topology, where all nodes are connected to each other, to all other nodes. So this is one of the most robust and most um, robust way of networking, and but it's very expensive. So were some of the physical organization of networks. Then there is also internetworking, which is connecting together any number of direct connected networks. And the largest is internet. Internet is basically nothing but interconnected network. Like, let's say I am connected to my Wi-Fi router, and my Wi-Fi router connected to um, other ISP providers, and the ISP providers connected to other from where it got the license to provide me via internet. So that's our in the same way all those are connected together. Okay, so that connection is called as internet. All right, then we have some categories of networking size. First, we have DANE, desk area network. For example, in your labs, university labs or in offices, that is an example of DANE, desk area network, in which just two or more communicate with each other. Uh, so that could be an example of DANE. Or if you just connect your computer with your phone or something else, or you just sort of these sort of things, then we call that DANE. And then we have lane, man, and Wayne. We'll discuss this one by one. Okay, so first then, making all component or desktop computers available to other computer on the network. CPU, unused computing power can be used by other computer on the network, hard disk, video display. So through then you could make available your different components of your computer to other computer over the network, and yeah, that could be used. So that's just giving the utility of why we could forward purpose DAN could be used. Then we have LAN, local area network, which is again a collection of nodes within a small area, like in your university, or if we go big, then it could be a big office, and or the nodes are linked in a bus, ring, star tree, whatever topology. And the benefit of using LAN is that it could be used for sharing hardware, sharing software and data, and there is a consolidated wiring or coupling, and simultaneous distribution of information, more efficient person-to-person communication. So mostly in offices or in universities, in big universities, there is a area network, local network, or if we go big, and a simple place or simple area, a small area could also come under the local area network definition. Then we have main, which is metropolitan area network, which consists of many local area networks linked together. It could span up to a few miles, which you could say that a city could come under a metropolitan area network. So if the network in a city could be labeled as man. Then we have a wide area network, which consists of number of computers connected network, including lane. So it is when wide area network is the connection of different lanes. Okay, so the connection of different local area networks into with each other is called WAN or wide area network. Okay, so yeah. Then we have security of our network. So whenever you're communicating with other person over the internet, there's all that it is always comes with a risk, because who knows that if your data would be secure, if you are sending over the internet, because that could also be traced back. Okay, uh, the wires through which you're sending, that could be traced, or your packet could be stolen. That could also happen. So for that, you need to have some sort of security in your network. And enterprise and internet networks corporation, government agencies, and other organizations have created their own internal network. So for that purpose, to make it secure, the internet, different government agencies and all that have created then internal networks. So what happens is there are firewalls. Firewall. We will just try to define the firewalls. What is firewall basically? Firewall is just you could say, I'll just give you an analogy. Let's say you are a university student. Okay. Let's say you are a university student, or you are just, let's say you are doing some, you know, you are an employee in some office. Okay, there's a biometric over there. Okay, you have to verify biometrically before you go inside. Other people who are not employed cannot go inside. Okay, so that's would be an best analogy to explain firewall. Firewall is the same thing. It's just a set of programs that monitor all communication passing into and out of the corporation's intranet, and it helps prevent uh, you know uh, some security risks, but does not eliminate unauthorized access. So it just it just keeps an eye on the packets which are being sent over the internet, who is watching what, and that sort of things. You could also name is the watchman in the internet. Okay, the watchman in your particular intranet. So that's what firewall is. So then we have problems. Okay, in software architecture of network, there are some when we connect several different machines running different operating systems, Windows OS, Mac OS, Unix, VMS, whatever. Okay, and they are trying to send different things, different files, or different sort of things. Okay, now there are different devices. My mobile phone is not the same as yours. My laptop is not the same as yours. So how could they communicate with each other? They are not similar. Take an example here. Let's say you only understand English, and the other person only understand Chinese. Okay, one person understand English, and the other person only understand Chinese. How these two people would be able to communicate with each other? There isn't any way there. Okay, uh, so how could they communicate with each other? There need to be some way in which different people would communicate with each other. Similar case, there are different operating systems or different devices, and they are doing different stuff. How could they communicate with each other? So the solution for that is uh, a standardized set of rules have been created, which are called as protocols, that when followed will allow an orderly exchange of information. And a collection of these programs is called protocol suite, and must be on all computers or nodes in the network. In order to send data over the network, the necessary program must be executed. So in network architecture, the protocol suite and the general scheme that guide the network rules is called as the network architecture. Now, there's one other problem that collision could occur. Collision of information are caused by two computers simultaneously attempting to send the same information in the internet. And the solution for that is different network have different protocol suites, like Apple computers, local talk protocol, which for that the permission must be granted before information can be sent along the network. Then we have token ring protocol for IBM early use. Tokens picked up by a node signifying that a message is about to be sent. and the computer sends the message and replies the token so that it could be used in the network. Then we have Ethernet cable, Internet protocol, or Xerox. I think it's a little bit outdated, but it's not being used. Collision not avoided when they occur, but both detect the other's presence, stop at sending, wait a random amount of time, and send again. So these are different protocols which are used to avoid collision of information between two devices. Now there are in the networking architecture there are different layers. Okay, different layers. So when a computer is communicating with other computer or the internet, so there are different layers which they have to go through in order to communicate. Okay. So first we have FTP, file transfer protocol, which is used to send different files over the internet, or we have HTTP, hypertext transfer protocol, which is used to transfer, which is one of the most widely used protocol, and it both of these work upon TCP, transfer control protocol, work on that protocol, and then we have NV. Um, it is a virtual network, and that use UDP. You'll get the idea about TCP and UDP. Basically, the difference between TCP and UDP is that TCP first build the connection. Let's say I'm communicating with another computer. First, if I'm using TCP protocol, it would first build a connection between these two devices and then send data through that. But in case of UDP, it's not that. In case of UDP, then the data packet is sent, whether the receiver get it or not, but it's being sent over the internet. Okay, so that's the difference between these two. Then we have then both of these in the third layer we have IP protocol, internet protocol, which uses different IP addresses to identify which node uh, to send the information to, and then we have networks, different networks below that which are connected through the same way. So that's how our and this is the simple network architecture which works. Now I would recommend one thing here, that if you want to get a detailed idea about these things, you must try to search the architecture of internet and how does communication over the internet occurs and how does it works. So search search about these sort of videos or whatever medium you like, and you get a detailed idea about this, because it's very important concept. So the internet is referred to as a packet switching network. So why internet is called? What's a packet switching network? Packet switching networks means each packet is being switched. Let's say I'm transferring some data to my friend. Okay, so there are lots of uh, devices in between. Like I am sending it to my router has to send it to the ISP provider, the ISP provider would send it to other, and then my friend would get the packet of information which I have sent. Okay, so how would the computer understand that I have to send this way, or this way? Okay, so that's where the packet switching comes in. It switches the packet, it routes the packet into different routes so that the packet could reach uh, the destination in a minimum time. Okay, so what is packet? What is packet actually? It is a unit of information created by TCP protocol software for transmission over the internet. So if in your networking class you would get a detail you'll get a detail you'll know in detail about how does this TCP transfer control protocol works, and how does your the message which you just sent is being divided into different packets. Okay, different small packets, and then transmitted over the internet. So once a file is requested, it is splits into packet. Each packet is assigned a number, and each packet contains information regarding content, where it came from, where it's supposed to go. So when your message reaches the TCP protocol, it divide this message into different packets, attach different address information, like where it need to go, where does it belong to. So it attach all those things with it, and then it's being sent over the internet. So as the packet travel through the internet from the network to internet, each packet may not travel through the same path through the internet to its destination. So each network has its own packet limiting size. Packets are often packaged and repackaged. They are reconstructed in order when they reach their destination. So that's how the communication works. You will get a detailed idea about this in your later courses. I'll just try to give you an overview of how this works. Alright, so there's again a problem. If someone wants this World Wide website, he must find a home for it. So here is the thing. Have you ever heard about website hosting? What does that mean? And have you ever heard about server? What is server? What does it do? So now here's the thing. Whenever you are making your website live over the internet, you need some place where you could store your website. Okay, where you could store your website, and people, when search about your website, they could uh, get the content of your website from there, because you won't be always available, and you won't be always available, and you're from, or you could be online all the time uh, for your customers or for your users to reach your website. So for that, you need to make it live. You need to put it somewhere from where your users could get it at any time. That place, the place, the storage or whatever, where not the storage, but the place where you put your website is called as server. It serves the website, or the content of website, to as per requirement, to the people who request it, or the computers which request the content of any website. So server, what is server? It's a dedicated computer that's part of a network. The hard drive contains files that are served to whatever requests them. Could be data, programs, or home pages for the word www. And the server normally runs the networking software. And then you have a client server model. This is a model of communication between two networks. Here, one is client, which requests for certain data, and the server gives the data. So that's how one computer, the client requests information from another computer, the server, and the server gives the client the data, the information which is being requested. Then client computer can run any type of operating system as long as they have the ability to use internet protocol. So that's obvious that if any client is using the internet protocol, then they can use any operating system and can communicate with the server and request it for any information. So there are different type of important nodes. There are different type of nodes which are important in network. We have hub, switch, bridge, gateway, router. Mostly router is being used nowadays. So what is hub? Hub is a device that repeat or broadcast the network stream of information to individual nodes. If you ever have you must have seen in labs in universities, there is a device from which every wire is being connected. You could plug in that wire with your computer, and you know, and you would be you would get into the network, or you can be part of the network. So that's what hub is. It's a device that repeats whenever some information is being sent to the hub. It repeats or broadcasts the network stream of information to individual nodes. It broadcasts that to all the nodes which are being connected to the hub. It's a physical device, and all the devices which are being connected to each are also physical via twisted pair cables. And switch is a device that receives packets from its input link and then sort them and transmit them over the proper link that connect to the node address. So switch is kind of more intelligent than hub. It knows where to send the different packets, and it organizes them whenever they reach the switch and then send to the node address. And then we have bridge. It's link between two networks that have identical rules of communication. And then we have gateway. It's also a link between two different networks that have different rules of communication. Gateway is used to communicate different sort of networks. Then we have router. It's a node that sends network packet in one of many possible directions to get them to their destination. So that's the function of routers. Alright, then we have trace route. It's basically a program that allows the tracing of packets over the internet or any network using TCP/IP protocols. It uses a special number called TTL, time to live, contained in a place at the beginning of each packet sent over the internet. So the number is originally set to 255. Each time it receives by a router, it's incremented by 1. If the TLN numbers become 0 before reaching its destination, the router which happens and make an error message time exceed with the address of the router stop message from circulating forward. So it's a TLS, trace route. It's a program that is used for tracing every packet of the internet. So it uses a special number, means it uses some number to TTL, which is time to live. So whenever a packet is being sent over the internet, it starts with the 0. Okay, so whenever the packet is being sent, it's start with 0. Originally it is set to 255. Each time it is received by a router, it's decremented by 1. Whenever a router receives it, it's decremented by 1 till it reaches 0. And when it reaches 0, you get an error message called time exceeds. So that's how this works. And stop message from circulating forever. That's the purpose of this TTL. Alright, so that's all for this lectures. I think you get the idea about just simple overview of networking. I try my best to get you an overview of what does networking means in communication. In upcoming lectures, you will get a detailed idea about what is networking, and I think there's a whole subject dedicated to networking. If you want to deep dive into that, you could pick up any networking um, book, and you could read about that. So for now, that's all. See you in the next one. Till then, keep learning and keep improving yourself. Thank you.